let's take a look at the notes for today, which is day 5. In the opening exercise, they want us to write a proof for the following question. They tell us DE and DG are equal. They tell us EF and GF is equal, and that's given. So we'll go ahead and copy that. And if I'm looking for another congruency, I can see that both triangles share a common side. So DF is reflexive. DF is equal to DF. That's a reflexive property. And the triangles are congruent by side, side, side. So triangle DEF is congruent to triangle DGF. And that's because of side, side, side congruency. But they want us to prove that DF is the angle bisector of EDG, which means for it to be an angle bisector, angle 1 and 2 have to be congruent, which they are. Angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent, which means that our DF is indeed an angle bisector. And the reason is two congruent angles cut by a segment cut by an angle bisector. Or bisector cuts an angle into 2 equal parts. So today we're going to examine 3 possible triangle congruence criteria, 2 of which don't work, and we're going to take a look at angle, angle, side, 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 angle, and angle, angle, angle. So let's take a look at side, side, angle first, also known as angle, side, side. And yes, that does spell a bad word, another word for donkey. So let's take a look at this. So maybe we prefer this one instead, side, side, angle. Observe the diagrams below. Each triangle has a set of adjacent sides of measures 11 and 9, as well as a non-included angle of 23 degrees. Yet the triangles are not congruent. As you can see, this triangle, a very different size from this triangle here. However, if you look, you have a side, and an angle, congruent to a side, and an angle. Yet the 2 triangles are completely different shapes. So you can kind of see that the side-side angle or angle side-side doesn't work, okay? Now, I tell you to examine this composite made of both triangles. If you think about your compass point at B and your pencil was at T and you swung it around and made an arc, okay? That's why you're getting 2 separate triangles that are of different shape, even though they have 2 congruent sides and an angle that's congruent as well. So you can see from the radius of your arc here that this is 9 and so is this 9. So you can see that BC over here gives us this triangle, and then BT over here gives us that triangle. So angle, side, side doesn't work. Here's another one. Angle, angle, angle. So there's 2 equilateral triangles there for you. And of course, we know the measure of each of the 3 angles, don't we? If the sum is 180 and we divide it by 3, each angle, of course, is 60 degrees. 60 degrees. And you can clearly see that even though the angles are equal, these 2 triangles clearly not congruent. They're the same shape, but they're different sizes. So does angle, angle, angle congruency guarantee that 2 triangles are congruent? No way, no how. So keep this in mind. Side, side, angle, 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 angle do not determine 2 triangles are congruent. I call this donkey theorem because you know why, right? Angle, side, side, or side, side, angle. Do not get trapped or caught using donkey theorem. It doesn't work as we saw on the previous page. How about this one? Consider a pair of triangles with 2 angles and a non-included side. So here are the 2 angles, B, C, and AB, corresponding to E, F, and DE as well. If 2 angles of one triangle are congruent to 2 angles of another, what can we conclude about the 3rd angle A and the 3rd angle D? Well, by the triangle angle sum theorem, we know that the angles have to add to 180. So if these two are congruent to these two, then obviously the sums are equal, which means when we subtract the sums from 180, we're going to get the same thing for A as we do for D. So technically, because A and D are congruent, we actually could prove these two triangles congruent by this angle A, this side, and angle B, which is absolutely a true and verified form of congruency. So since we don't really need that third angle, it's sufficient to say that if you know two angles and a non-included side, angle side will work. All right, and there's our congruency criteria for today. So angle side. So if the measure of angle CAB, so let's mark it, is congruent to C prime, A prime, B prime, and CBA is congruent to C prime, B prime, A prime, and then you have a non-included side, AC, A prime, C prime. Then the triangles are congruent. So the notice here is to be careful and watch out where your side is. The side is not included between the angles. So most kids get, in terms of, what they get confused is they get angle side and angle side angle confused because they accidentally think that the side is here when it's not. It's over here on this side. So be really careful. If it were AB that was congruent to A prime, B prime, it's angle side angle. But because it's AC, which is not included, it's going to be angle side. Okay? Be careful. All right, moving on. Here's an example. So we have perpendicular lines all over the place. AB is perpendicular to BD, and ED is also perpendicular to BD, which tells me I've got right angles, and the right angles are equal. They also tell me AE bisects BD at C. Let's see, BD. So this is congruent to this. And we want to prove that triangle ABC is congruent to triangle EDC. Okay, so a couple things. We could use a pair of vertical angles here. We could, and then use angle side angle. But since we were just talking about angle side, how about we talk about angle A and E? You have two lines, AB and ED, perpendicular to the exact same line. That means they're parallel, which then, of course, leads to alternate interior angles. So I am going to use an angle side just because we talked about it. But you could do this proof using the vertical angles and a different congruency criteria. So first thing I'm going to say is that AB is parallel to ED. And the reason is two lines perpendicular to the same line are parallel. That gives me angle A congruent to angle E. And the reason is parallel lines imply congruent alternate interior angles. Step 4, I'm going to get those right angles. So angle B and angle D are right angles. And that is because perpendicular lines make them. So perpendicular lines form right angles. Then I'll say they're congruent. So first you have to state that they're right angles because of the perpendicular lines. Then you have to say that they're congruent because all right angles are congruent. So angle B and D are congruent, and that is because all right angles are congruent. And then we got to get the side BC is congruent to, let's see, DC, and that is because of the segment bisector. So segment bisector forms two congruent segments. And step 7, we have now all three of the congruencies stated. So triangle ABC is congruent to triangle EDC, and that is because of angle side congruency QED.